Sometimes when we're trying to simplify a rational expression, or work with rational expressions more generally, we'll come across a situation where we have factors that appear to be in common, but the order of the terms is different. And this is something we have to treat a little bit carefully. So, to see an example of this happening and think about how to treat this, let's consider the rational expression 16 plus 12x minus 4x squared minus 3x cubed over 9x cubed minus 18x squared minus 16x plus 32. Each of these has four terms, so we'll factor each one by grouping. For the first one, filling in our terms in the order we come, we have 16 plus 12x minus 4x squared minus 3x cubed. Looks like the greatest common factor in my first row is a 4. 4 times what is 16? 4 times 4 is 16. 4 times what is 12x? That'll be a plus 3x. 4 times what is negative 4x squared? That'll be a negative x squared. Negative x squared times positive 3x gives me negative 3x cubed. Yes. So this polynomial factors first as 4 plus 3x times 4 minus x squared. Remember, we need to factor fully. 4 plus 3x is linear, so that's prime. But then 4 minus x squared, that's a difference of squares. That'll factor as 2 minus x times 2 plus x. And now all of those factors are linear, so all of those factors are prime. What about our denominator now? X cubed minus 18x squared minus 16x plus 32. Again, we'll start out factoring by grouping. Taking the terms again in the order they come, 9x cubed minus 18x squared minus 16x plus 32. First row, greatest common factor is a 9x squared. 9x squared times what? Gives me 9x cubed, that's just an x. 9x squared times what gives me negative 18x squared, that's a negative 2. X times what gives me negative 16x, that's a negative 16. Negative 16 times negative 2 does indeed give me positive 32. So I have an x minus 2, and then a 9x squared minus 16. First factor is linear, so it's prime. Second factor looks like a difference of squares, right? I've got x minus 2 times 3x all squared minus 4 squared. So I end up with x minus 2 times 3x minus 4 times 3x plus 4. So when we rewrite our rational expression with the numerator and denominator in factored form, our numerator factored as 4 plus 3x times 2 minus x times 2 plus x. Our denominator factored as x minus 2 times 3x minus 4 times 3x plus 4. And the first thing I noticed looking at this is that none of these pairs of factors are identically the same. But I have two pairs that look really, really similar. First, I have this pair, 4 plus 3x and 3x plus 4. So these are the same except the order of the terms. Right? I've got a 3x in each and a 4 in each. But these are equal. Why are they equal? They're equal because addition is commutative. So I can just switch the order of the terms. If the operation is addition, I also have this pair. I have 2 minus x in the numerator and x minus 2 in the denominator. Now subtraction is not commutative, but we know that reversing the order of subtraction just reverses the sign of the result. 2 minus x is not equal to x minus 2, but it is equal to the opposite of x minus 2. So that gives us a way to actually get an x minus 2 to match up between the numerator and the denominator. Let's put that into practice. So I'm going to just rewrite factors from the numerator, because I like my variable to appear first. 4 plus 3x, we said that's the same as 3x plus 4. 2 minus x, we said that's the same as negative 1 times x minus 2. And then the 2 plus x doesn't have anything to cancel with, so I'm just going to leave that alone. And then in my denominator, I'm going to leave the factors in the denominator alone. I have an x minus 2. I have that 3x minus 4 that isn't going to cancel with anything. And then I have 3x plus 4. So now my 3x plus 4's cancel out. My x minus 2's cancel out. And I'm left with a negative 2 plus x over 3x minus 4. And again, I can leave that as is, or I can distribute the negative sign, negative 2 minus x over 3x minus 4. Either form is okay depending on what I want to do next. But the key takeaway here is when we want to reverse the order of terms in subtraction, it costs us a negative sign, right? We need to introduce that factor of negative 1 in order to reverse the terms in subtraction.